Hello, good evening. Can you hear me?
Yes, sir.
Yeah, how are you?
I'm good. How are you, sir?
Yeah, Alhamdulillah, I'm fine. Okay, hope everything is good from your side. Yeah,
Yes, I'm also good. Long time.
yeah, after a long time, we'll meet for another training session. Okay, so I
Yes,
hope you can get all of those from beginners to advanced level, and then you can easily learn the agriculture precision. Okay, all of topic I try to complete it. Okay, no problem. So let's go. First of all, I try to discuss about our course module. Okay, so after completing the full syllabus, what you will learn, okay, and you want to make a research title after completing this training, and then you try to publish the scientific paper also. So that's why I also try to give you the research based analysis, and I also try to all time I will try to show you some reference paper or reference scientific paper for agricultural precision, then you can easily get the idea, and then you try to
yes.
implement. Okay, so let me share my screen.
Okay, sir.
Okay, can you see my screen? Is it visible?
Yes, it is busy.
Okay, thank you. So let's go.
Sir,
Yes, please.
can you remove my computer, my pop-up name?
Okay, okay. Okay, so basically you want to enroll this training program. Okay, this is the precision
Sir,
agriculture using remote
sir,
sensing. Yes, please.
okay, can you remove this my name on the screen because it is just hiding something.
Okay, okay. So I'll do it. No problem. No problem. Okay. Okay. So basically, you want to enroll this online training program, uh, precision agriculture technology, how we can easily use the different types of precision agriculture tools and practice that uses data, sensors, or automation to optimize the farming operation for higher efficiency and lower environmental impact. Okay, so first of all, I try to explain about that course syllabus. So basically, geospatial data analysis in precision agriculture, it mainly focus this type of topic. Suppose soil mapping, create the detailed maps of texture, then soil nutrient level. Okay, so here we find out the high nutrient, here we find out the low nutrient, then soil pH, then moisture content. Okay, and identify site specific need for the fertilizer. Okay, suppose this place I need the fertilizer and this place I not need the fertilizer. So this type of place we can also identify using the soil mapping, so, as well as soil corrective application. Okay, so this is the process for the soil mapping, as well as we also do for the crop monitoring. Okay, crop monitoring basically track the crop growth and detect the water stress. Okay, then pest and diseases we can also identify using this way, and estimate the plant vigor and also yield prediction. It's very important. Okay, so it can be crop yield prediction or different types of crop, we can simply predict the yield. And then support decision for the irrigation, we can also use the irrigation, then pesticide use and harvesting. So this type of things we can also apply for the crop monitoring. So I'll try to show you that all of those step by step practically you can easily get this type of knowledge, and further you can also apply for your own study area. Okay, and also we can also identify the productivity zoning. Okay, suppose this place we can easily segment into the zone based, suppose yield history, then topography, soil quality, and climate data we can also including, and identify the productivity zoning and maximize the potential in fertile areas, and manage the less productivity zone we can also identify. And application of the agriculture input, we can easily use the fertilizers, then pesticide or seed. Okay, it reduce the cost, avoid the waste, as well as we also do the irrigation management. It's very important. So irrigation management basically optimize the water use with soil moisture map. We can easily identify where the high moisture, where is the low moisture. Okay, where we find out the low moisture, we need the irrigation. Suppose where I find out the high soil moisture, we don't need the irrigation much. As well as apply water only where and when needed, we can also identify. And prevent under or over irrigation. Suppose this place have lot of water, but you also put the irrigation, so it just waste your money. So that's why you can also identify, prevent under or over irrigation using the irrigation management. So I'll try to show you that all of application, how we can easily identify this type of things. And basically in this online training program, we also focus understand the principle of the precision agriculture in remote sensing. Then we are just use at the Google Earth engine, as well as we also use at the some machine learning in Python, as well as also use some collab notebook we also use. And we also discuss about that how we can easily processing and analyzing the remote sensing data, as well as I also add some drone imagery because you also want to focus for the UAV image, so aerial
Yes.
image. So I also try to add this type of application, how we can easily apply the drone imagery or UAV imagery to identify the agriculture monitoring or precision agriculture. We'll discuss about that. And apply remote sensing technique to monitor and manage the agriculture resources and develop the interpret and remote sensing data for decision making agriculture. So you already completed my another 7 days online training program and also complete. So I hope you can also know about the basic programming skill about the JavaScript and Python, as well as you already know about the basic GIS, geographic information system. Okay, so that's why I am not going this type of topic because you already know about that. So we don't waste our time for the programming or other thing. You already know about that. So this same concept we also use, and further we also try to use this type of technique for the precision agriculture. So now for first introduction to precision agriculture. Today I discuss about that and remote sensing, an overview of the precision agriculture definition, importance, then historical development. Then we talk about some basic remote sensing, how we can easily connect with the agriculture. We also discuss about that, and also discuss about the remote sensing platform and sensor. So different types of satellite sensor. We also discuss how we can easily connect with the agriculture, because there are a lot of satellite imagery is available, but which satellite image is more effective to identify different types of agriculture precision. We also discuss about that, as well as we also discuss about that Google Earth engine. You already have the account for the Google Earth engine, and also you already have the Google Earth engine interface and tool. You already know about that, how we can easily set up the account, how we can easily create the environment. So I just ignore this type of part. Then we also discuss about this type of things. Suppose different types of remote sensing data. It can be optical, how we can easily use the optical data, thermal data, radar data, different types of data sources, Landsat, Sentinel, MODIS. Okay, how we can easily spectral signature of probe. Okay, using the different types of vegetation indices, and assessing and the visualizing the remote sensing data in Google Earth engine. We also discuss about that, and we also discuss about that image processing and analysis in Google Earth engine. Okay, suppose atmospheric correction, radiometric correction, geometric correction, and image classification. You already know about this type of supervised, unsupervised, but in this case I also add some more details. Suppose how I can classify the drone image. Suppose this is one kind of drone image. So this drone image, how I can classify? Suppose it's a one kind of drone image. So this drone image I just classify and identify. Suppose classification you can see, I just apply and identify, suppose sugarcane, forest, build up, and barrel land. Okay, so this type of drone imagery basically very high resolution imagery. So this type of drone imagery, how we can really use and identify, suppose land use, land cover classification using machine learning. It can be supervised or unsupervised. So this type of things I also try to explain. Then you can easily get the idea how we can easily take the drone image, and then how we can easily use this drone image to identify for the classification. Not only for the classification, different types of work. Suppose different types of remote sensing work. It can be NDVI, EVI, or anything we can do. No problem. Then we also discuss about that implementing image processing and classification in Google Earth. We'll discuss about that. And we also discuss about the vegetation indices and crop monitoring. So basically, in the agriculture, we are just use different types of indices. Okay, different types of vegetation indices. If you simply search, suppose vegetation indices list in remote sensing, simply search, then we find out that lot of vegetation indices list. If you change, just click on here, then I hope it will, yeah. So this is the list of vegetation. So you can see it provide that very long list. So this type of things we also use for NDVI, then SAVI, then MASVI2, then OSAIV. So it's provides a lot of equation for the different vegetation indices. So how we can easily use this type of vegetation indices, and then further how we can easily do different types of things. Suppose how we can easily identify crop health monitoring, or also crop stress monitoring, or water stress monitoring. So this type of things I try to explain. Okay, so there's a lot of indexes available in the remote sensing for the vegetation. Okay, so if you check this, so you can see remote sensing indices. So we find out the different indices, how we can easily create this type of a spectral profile. Okay, suppose bands value, pixel value. Okay, we also discuss about that. You can see this is the NDVI. It's one kind of remote sensing index. ENVI, ENEVI, then NWI, okay, then modified soil adjusted. So different types of index are available for that, only for the agriculture or agriculture monitoring. So this type of agriculture index or indices were used for the different purpose to identify, suppose, crop health or crop growth. So different types of crop monitoring were used this type of index. Also you can see this is the forest canopy density, FCD. Okay, so this is the formula about that, AVI, shadow, different types of band we also use to compute this type of things. So you can see for NDVI how we can easily use the NDVI. Okay, as this is the formula about the NDVI. This is the EVI, enhanced vegetation index. Okay, this is the formula about that. So this type of things we are just use and identify for the different types of crop monitoring. Okay, or forest canopy. So we'll also discuss this a bit later about this type of things, as well as we also discuss about the soil and water management. Okay, soil and water management using remote sensing. Suppose soil moisture. Okay, how we can easily compute using the different sensor. It can be Landsat, how we can easily monitor the soil moisture. Then health monitoring. Okay, remote sensing technique for soil analysis. Then water management in agriculture. Suppose water efficiency, how to use the water efficiently, we also discuss about that. And also irrigation schedule, suppose for your crop when you need to irrigate, when you need. Okay, so this type of thing we discuss about that. And analyzing soil and water data in Google Earth Engine. Okay, as well as we also discuss about the crop yield prediction model. Okay, how we can really develop the yield prediction model using machine learning or deep learning. We can also apply this type of yield prediction model. And remote sensing for yield estimation we also discuss. And also pest or disease monitoring, or identifying and managing the crop disease, we also discuss about that. So it provide topic, lot of topics it will be covered in this online training session, as well as machine learning in precision agriculture, or application of AI and ML in agriculture, case studies we also discuss about that. Okay, and if you check some scientific paper, suppose I simply go to the Google Scholar, and already lot of review paper is already published how to use Google precision agriculture for remote sensing analysis. So if you simply search about agriculture precision using remote sensing, so you can find out this type of, suppose, again, application of remote sensing in precision agriculture, a review paper. Just simply check, then we find out, okay, lot of application. Okay, how to use the remote sensing in the agriculture precision for the different types of way. Okay, so you also try to read this type of paper, then you also get the lot of idea how we can easily work. Okay, so how we can easily
Yes.
work with the ground data. Suppose you can see they are using the aircraft scanning and take the UV imagery. They are also use the ground sensing for carbon. So this type of tool we can also use in our field. Okay, so this type of tool we are just used for taking the carbon dioxide or gas emitted, we just measurement using this tool, as well as this type of it's provide the data from your ground. So further this type of data we are just using the remote sensing to check the calibration or check the accuracy or create the map. So it's very helpful to use this type of tool. Okay, so you also try to read this full paper, then you also get a lot of idea about that application of of your agricultural precision. Okay, suppose you can see evapotranspiration, so ET, how we can easily compute the evapotranspiration and how we can easily connect with the agriculture precision. Okay, as well as if you check the another one is for soil moisture. Okay, how we can easily connect the soil moisture in the agriculture precision. if you check the another, suppose nutrient management, so how we can easily monitor the nutrient for our study area or crop field. Okay, if you check suppose another disease management, so how we can easily management the disease. So different types of application, as well as they are also add the how we can easily apply this type of method, as well as water management. Okay, if you check the another crop monitoring and yield prediction. Okay, then progress the made needs and challenges they also add. So this type of application they are including in this application of re- remote sensing in precision agriculture. So you also try to read it, then you also get some practical idea. So I will send you all of materials, and I also open a Google Classroom, so from here you can easily get all of those, no problem.
Okay, I'll get your material, even those scientific paper will be in the classroom.
Yes. So I will send, no problem.
Oh, okay.
Okay, so let's go. So today's session we discuss about that some. Okay, let me open my slide. So basically, this is our precision agriculture with machine learning, deep learning, and geospatial data analysis. Yeah,
Please.
yeah. Can you see my screen?
Yes, I see. Can you maximize the screen? Because I see the white face of your screen.
Okay, so it show the small screen or big screen?
A small screen, small screen.
Okay, just a minute.
Maybe you to remove your name and picture in the screen because it is occupying the right space.
Okay, so now it's okay or not?
It is okay. But I'm saying about your account, your name and your face, your picture. Okay. It's occupying the right space. You
Okay, so now it's okay.
so let me send you. You can see it. You
Yeah,
can
send
see
me the
how
message. Yeah.
I
Send me the message.
on WhatsApp. You,
Yeah.
yes, you can you can see it. Check your WhatsApp.
Okay. Okay, so
You see?
yeah, I can see. So this thing you can also rearrange. So for that, you can simply click on the, if you check, you can simply click on here and click on this option, more option, and you can see the adjusted view. Okay, click on the adjusted view.
Click here.
Adjusted view.
Adjusted view.
Yeah.
Adjusted view.
Yeah. So now you just click on the sidebar.
Where?
You can see the more option.
Sidebar.
Yeah.
Yes.
Adjusted view.
Yes.
You can see the sidebar. Okay, then it will be, I think it's show the sidebar.
Okay. Sidebar. Yes.
So now
Now
it is,
it's okay.
yeah. Okay, so let's go.
Now it's okay.
Okay, so let's go. We start precision agriculture with machine learning, deep learning, and geospatial data analysis. So basically, in this training, I will try to show you the some example for machine learning, as well as also show some example for deep learning, and also help of geospatial data analysis. Okay, so it cover a lot of topic. I hope it will be covered. So let's go start one by one. So first of all, geospatial data analysis in precision agriculture. So basically, we already discussed about that. So this basically these four types of application. Suppose soil mapping, crop monitoring, productivity zoning, and application of agriculture input. So basically, these four types of analysis we are doing using the precision agriculture, and help of geospatial data. Suppose soil mapping, we created the detailed maps for texture, nutrient level, pH, and moisture content. Identify site for specified needs of the fertilizer and soil corrective applies, and also use the crop monitoring. Suppose crop growth or water stress or diseases for irrigation. So this type of things, crop monitoring. So basically, these 4 types of application we are just apply in our precision agriculture topic. So basically, the key application in remote sensing in a precision agriculture is that irrigation management. It's very important how we can easily management the irrigation, then nutrient management, then diseases management, then also wood management, and also crop monitoring and yield estimation. So these 5 types of application are the key application in precision agriculture. Then why use the satellite for agriculture application? Basically, timely, we find get all of data, then objective, then local to global coverage, we can easily get the result for whole study area or big study area, then useful for observing areas that are inaccessible. Suppose some place you cannot visit the physically, so this type of place we can easily monitor using the remote sensing, and as well as monitoring the plant growth and estimate the crop productivity, we can also estimate, and then assess the soil moisture and irrigation requirement. Okay, suppose irrigation requirement is different on the soil moisture. So if you know the soil moisture for your crop field, then you can easily get the idea for this cropland soil irrigation is needed or not. So we can easily get the idea from here, and then identify soil and crop characteristics and condition. Okay, as well as we can also better forecast precipitation and crop disease, we can also identify using the application of agriculture in satellite. Then maximum crop yield while the reducing the energy consumption. Okay, maximum crop we can find out while reducing the energy consumption when you apply the satellite agriculture application. Then avoid the waste of farm input. Suppose water, fertilizer, and pesticide. Suppose for your cropland don't need any kinds of fertilizer, so then you can simply skip it. You can easily don't need any kinds of irrigation, then you can skip it. So this type of waste of farm input we can easily identify using the help of remote sensing, using the help of satellite images. So for my cropland, the water is needed or not. So for my cropland, fertilizer is needed or not. So for this cropland, have any pesticides is need or not. So this type of things I can easily identify using the help of satellite or drone imagery for my agricultural land. I can easily identify. And then application for agriculture and food security. So it's very important for the food security. So we can easily crop monitoring. Suppose we can different types of way for crop monitoring. Suppose phenology, then crop area, crop type, crop condition, then yield, then irrigated landscape, then flood, drought, then frost, accurate and timely reporting of agricultural statistics. We can easily get this type of things. Then crop forecasting, we can also forecast the crop. Suppose we can suppose you have some historical data of ground truth data for yield data. So this type of yield data we can easily use, and further we can easily identify for the crop yield estimation. We can easily identify for the future crop estimation. So in crop production and food supply per region and country, we can easily identify for the crop forecasting. So this type of forecasting I'll just show you that how we can easily predict for the crop yield prediction. And then market stability. Suppose lowers uncertainty and increase the transparency of global food supply, reduce the price volatility by the anticipating market trend with the reduce the uncertainty. We can also get this type of idea. And then humanitarian aid, so monitor the food security in high risk region worldwide, early warning of famine, or enabling the timely mobilization of an international response in food aid. So this type of thing is very helpful of the application for agriculture and food security. And biophysical characteristics derived from remote sensing. We can also get different types of biophysical characteristics. Suppose derive the biophysical characteristics of vegetation. Suppose chlorophyll content. Okay. So chlorophyll content is one kind of biophysical characteristics of vegetation. Suppose if the chlorophyll content is high, it means that vegetation is very good. If the chlorophyll content is low, it means that vegetation is very low condition or vegetation health is not much good. So we can easily derive from biophysical characteristics of vegetation from the remote sensing data. Then we can also calculate the above ground biomass. Okay, so I'll just show you that how we can easily compute the above ground biomass. Then leaf area index. Okay, leaf area index. So this is another way to identify chlorophyll content. Leaf area index or above ground biomass. Leaf area index basically it one side green leaf area per unit ground area in broadleaf canopies and half of the total net leaf surface area per unit ground area in the conifers canopies. And then also photosynthetic primary production. Okay, so this is the measurement the how much carbon dioxide vegetation takes in during the photosynthesis minus how much carbon dioxide plant release the during respiration. So this type of photosynthetic primary production we can also compute using the remote sensing. Okay, and photosynthetic primary production it's basically measurement how much carbon dioxide vegetation take in a during photosynthetic minus how much carbon dioxide the plants release during the respiration. So this type of things we can easily monitor help of remote sensing. Okay, then leaf area index it's another application. So leaf area index we can easily get the one side leaf area per unit ground area. Okay, and also chlorophyll content we can easily identify using the above ground biomass. And then we can also do this is another one, it's called the fraction of absorbed photosynthetic activity radiation, FAPAR. So basically it represents the ratio of solar radiation that is absorbed by vegetation, okay, for photosynthesis used for assessing the impact of the drought on vegetation. So we can easily identify the solar radiation, okay, how much solar radiation absorbed by vegetation using this method. It's called the fraction of absorbed photosynthetic activity radiation. So using this radiation we can easily measurement how much solar radiation is absorbed by vegetation. Okay, so there's a lot of ways. So I'll send you all of PDF, then you can easily read it, then you can get a lot of idea, and further we just apply the practically. Then satellites and sensor for agriculture application. So there are a lot of satellites are available. If you check, suppose you can check the satellite. So this is the satellite, this is the sensor, land surface reflectance, then evapotranspiration, land surface temperature, precipitation, soil moisture, vegetation greenness, and structure. So basically if you check Terra, it's one kind of satellite, then Aqua, then Xiaomi NPP, then AOA, so Landsat 8, Sentinel-2, Landsat and Sentinel-2, then International Space Station, Land Data Assimilation System, Global Precipitation Measurement, then CHART, Soil Moisture Active Passive Satellite, Sentinel-1. So this is the satellite, okay, and this type of sensor. So this type of sensor if you check MODIS, then this is another MODIS, then we find out the phrase, then OLI, Open Land Imager, okay, multi-spectral instrument, okay, harmonized. So different types of sensor we find out. Okay, and if you check satellite product, so this is the satellite product. So we can easily find out the land surface reflectance, evapotranspiration, land surface temperature, precipitation. Okay, so we can easily get the satellite product, soil moisture, then vegetation greenness, then structure. So if you check, we find out that one. So basically land surface reflectance we can get from this type of sensor. So MODIS, then VRIS, OLI, MSI, SLS. So this type of sensor we can easily find out the land surface reflectance are available. Okay, evapotranspiration is available only for the two sensor, MODIS and MODIS. Okay, as well as we also find out that you can see this is another one. So you also get the land data assimilation system. It also provides the evapotranspiration. Okay, and also put the molded output. We can also find out that evapotranspiration and land surface temperature we find out from this sensor if you check. So first Modis, then Modis, Breeze, OLI. So this type of sensor provide the land surface temperature and precipitation. It's provide this type of sensor, basically global precipitation measurement and also charts. So this type of sensor provide you the precipitation and soil moisture. If you check, so basically this sensor and this sensor, it provide the soil moisture satellite. Okay,
Yeah.
yeah, please. Now,
But also the tailored climate is one among the source of the precipitation, but I don't see there
okay,
tailored climate.
okay, track climate, it also provide the precipitation.
Yeah.
In this time it not showing in here. I think some mistake for this in here, so it's also show the precipitation, but the track climate also, or
Okay.
bioclimate is also added. So this thing I need to also update it further, as well as now embedding satellite image is also available for the alpha art model. So we also need to add this type
Yeah.
of things, then it also look more perfect, but I think it's a previous way. Then if you check the
Yeah,
vegetation
okay.
greenness, so this type of sensor, it provide the vegetation greenness. And if you check the structure provide only for the one sensor. It's called the Sentinel one. Okay, Sentinel one only provide the structure. So when you monitor the structure, then we just use the Sentinel one C band radar imagery we need to use. Okay, so this is the one kind of chart. So this chart help you, this chart show you the all of scientific product. Okay, so which sensor provide you the which data. Suppose you need the soil moisture data, so you can simply check which sensor provide the soil moisture data. You need the vegetation greenness data, so you can simply check which sensor or which satellite give you the vegetation greenness data. You need the precipitation data, so you can simply check which sensor or which satellite give you the precipitation data. So you can easily get the chart, and the chart further we also need to update it, because some new satellite is also provide the new data. Then it look perfect, but commonly this type of sensor we are just used for this type of land surface reflectance, evapotranspiration, land surface temperature, precipitation, soil moisture and vegetation greenness. And this type of product is very helpful to identify for the crop monitoring or crop health monitoring. It's very important to this type of sensor. Okay, then land surface reflectance, we already know about that. So land surface reflectance, basically it's provide an estimate of the surface spectral reflectance. Okay, so it estimate the surface spectral reflectance as measured at the ground level by accounting for atmospheric effect like aerosol, scattering and thin cloud, and useful for measuring the greenness of vegetation, which can be used for the determine and phenological transmission dates, including the start of the season, peak period and end of the season. So land surface temp reflectance. So now how I can check the land surface reflectance? So let's go try to check which satellite provide this information. Land surface reflectance provide, you can see the modis it provide. We can also get the OLI. Okay, it also provide the land surface reflectance, or MSI. Okay, provide this. So suppose I want to measurement for the land surface reflectance. So how I can do it? So it's very easy. We can easily open the Google Earth engine and then practically we can identify. So I'll show the one example. Suppose I simply search here land surface.
So increase the zoom level,
Okay,
please.
just a minute. Okay, so if you check, we find out that land surface reflectance, if you simply search reflectance, so then we find out all of data, where we find out that estimated surface reflectance, we find out land surface phenological yearly global, or you can see the surface reflectance daily. Okay, this is the surface reflectance. Okay, you can see the surface reflectance daily. Okay, and as well as we also get the some satellite imagery. Then albedo, I can see. Okay, so SUOMI, so this is the another things we also get from the surface reflectance. Suppose I want to use this data, uh, So this one I want to use. So this is the estimated the surface reflectance uncertainty we also get. So if you check the reflectance absorbed from the corresponding reflectance, and that will we're going to find out in here. Okay, so reflectance one, so these different types of band if you check. So this is the reflectance absorbed from the corresponding reflectance, scattering, sitting, and index one. So index two. So we try to use suppose this one, relay reflectance. Just import. So now you find out this type of data. So just I try to add without just map.add layer. So I want to check for the globally. Run the code. Okay, so we need to check. Okay, so we need to select the band, then it will be shorted the data. So let me take a variable. Suppose data set, then call the image collection and select the bands because there are a lot of data. So that's why it not capacity. I use this step reference 0 and paste, and also filtering the data. Suppose I put the filter date year of 2020, suppose 1st January, year of 2020 December 31. So now further I want to let me check the time period. This data set is available from 2020. Oh, sorry.
Yes.
So I put suppose 2024. We take a small study area. I think it's a take more time. So I simply choose a study area. Suppose I okay, it's loading. Yeah, loading. Yes. 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 So let me. Okay, suppose I take a study area. Suppose this is my study area. So this is my study area. So for this area, I needed the data. So just simply use the filter bounds function. So in this time, I not explain this type of function because you already know about that, how we can easily use this
Yes.
type of things. So just I simply
Yes.
filter bound with my study area, and then I create that median composite, and then click with my study area. Suppose geometry. So now I display for my study area only for this study area. Okay, it's done. So you find out this type of reflectance. So now we try to add the color. reflectance, where is the high reflectance, where is the low reflectance, try to check it. So just I simply take a plated. Suppose I want to show this type of color for the low reflectance. Get at the end to show suppose this type of color. Get at the end to show this type of yellow color, and high reflectance I show this type of red color. Just apply and also import the visualization. So now if you check, we find out.
So,
Yeah. Please, any question, please. Yeah, can you see my screen? Yeah, can you see my screen?
network issue, I think your screen doesn't.
Okay, just a minute. Okay, so now can you see my screen? Yeah.
Let me leave and then I will join. Again.
Yeah. Okay, it's okay now. Okay, so let's go. Okay, so now can you see my screen? Can you see my screen? Hello. Hello. Hello.
Yes, sir. Yes, sir.
Yeah, so that's okay. Yeah.
Yes, that's okay. The internet issues.
Okay. Okay. Okay, so we discuss about that reflectance. Okay, suppose surface
Yes.
reflectance and why it's very important for the agriculture monitoring. We discuss about that. So basically, surface reflectance. This surface reflectance is the important, very important in the precision agriculture, because how much significant, how much sunlight is reflected by the land surface at different wavelength. Okay, suppose for that we can easily find out the suppose high, if you check, so this type of place we find out the high reflectance value, this type of place, or some place red color is indicating about the very high, so this type of place we find out the high reflectance value, but blue is indicating about the low reflectance value. So surface reflectance is one of the most important input in precision agriculture, because it tells you how much sunlight is being reflected by the land surface at the different wavelength. and which is directly related to the crop health, soil condition, and vegetation type. Okay, suppose in this case we find out this type of place is the high reflectance. Okay, suppose solar reflectance is very high, we find out this type of place, and this type of place we find out the low reflectance. So this is the radiation very high, so for this type of place is not possible to get the good crop. We don't find out the good crop for this type of place. But this type of place, however, we find out the low reflectance, or we find out that sun surface reflectance is not much high, or sunlight is being reflected very low, this type of place. So we can easily find out the very good vegetation for this type of place, we find out. But red color is indicating about the very high mass sunlight is absorbed. Suppose you already know about that urban heat island. So in the urban heat island, what happened? In the urban heat island, in the urban, suppose for the different types of construction, different types of building, it absorb the sunlight. It absorb the sunlight. So that's why we find out the urban is very warmer than surrounding area. Suppose some place have a water body, some place have the vegetation. So this type of place low absorb the sunlight. Okay, not mass. But urban, suppose build up, settlement, construction, or barren land. So this type of place it absorb the lot of sunlight. Okay, and day by day it increase and make the urban heat island. But for the vegetation, but water body, so this type of feature is not much absorbed. The high mass of sunlight is not absorbed this type of place. So that's why we find out the good vegetation this type of place. Suppose I'll show the practical example, another one, just a minute, then you can get the concept. So in this time we talk about the surface reflectance. Surface reflectance. So surface reflectance, we find out, and what is the surface reflectance? Surface reflectance, basically sunlight is being reflected by the land surface at the different wavelength. Okay, and using the surface reflectance we can easily monitor crop health. Okay, then we can also monitor soil condition. We can also monitor vegetation type. Okay, so here is the high vegetation, good vegetation, low vegetation. So this type we can easily get the idea. So based on surface reflectance data, we can easily monitor this type of things: crop health, soil condition, and vegetation type. And what is the surface reflectance? Surface reflectance is mainly how much sunlight is being reflected, how much sunlight is being reflected by different surface. Okay, so it's called the surface reflectance. So just I will show you one example using high resolution imagery. It's called the NAIF. It's only available for the US. Okay, because it's very high resolution, and it's called 0.6 meter. Okay, high resolution imagery. It's only available for the US, but not available for the all globally is not available. Okay, so I want to use this image, and further I will show you that one practical example, then you can easily get this concept reflectance, how it will work. Okay, so just I import this image collection. Suppose I need this image for a specific boundary or a specific study area. Suppose I choose a cropland, it's also more better. So let me find out. Suppose this type of place is the cropland, I think. Yeah, it's a cropland. So I need a data. Suppose this is my study area. So for this study area, I want to identify crop health. Okay, so I simply draw my study area. So this is my land, and I put the name, suppose AOI. Okay, so now I want to filter this image collection for my study area. Suppose take a variable. I put the variable name, suppose image, and then call the image collection. This image collection I need to filter. So use the filter bounds function with AOI. Then I put here filter date. Suppose I put the filter date. Let me check the present time. it's available from 2002 to what is the last time 2023. Okay, I take the 2022. Suppose I take the image. uh
Central period.
so 2022 1st January from year of 2022 December 31. So I take this image. So now let's check how many images are available for this time. So just use the image function and use here the size function. So now it's computing how many images are available. So we find out the 4 images for my study area. So I used all of images and create the median composite. Okay. So now I just clip with my study area. So clip with my study area is the AOI, and then I want to display. So just I simply display map dot add layer and call the image and run the code. Okay, so let's go what it's showing in here. So we find out this type of imagery. So this is the imagery. It's very high resolution, so that's why it look like that. And in this imagery, so it show the, I think it show the natural color band combination. We can also change the band combination. So it show the red, green and blue. Suppose I want to show, suppose in here near infrared, then red and blue stressing, just like create the false color composite, then apply. So we find out this type of vegetation. So vegetation show as a red color. So if you check, we find out this type of place is the better vegetation, but this type of place is there is no vegetation, or there is not cultivated, or there is no anything. Okay, this type of place, this type of land, this type of land. But from this image here we find out this type of red color indicating about the better vegetation. Okay, so now what is the reflectance? Surface reflectance. Basically surface reflectance is the proportion of incoming solar radiation reflected from the surface and corrected for the atmospheric effect. And why it matters in agriculture? Basically healthy vegetation is strongly in the near infrared and less in the red. So if you check, suppose in this time healthy vegetation, so in this time healthy vegetation is strongly reflected near infrared. Okay, so I want to show the near infrared band. Just I show the one band, near infrared band, and apply. So now if you check the result and also compare the result, so for that I simply opacity, decrease the opacity. Okay, just a minute. Let me try to add the 2 layer. Suppose this is the layer for, just I import this layer. This is the near infrared. I want to display only for the near infrared band. Okay, only for the near infrared band. And I put it's a NIR. Okay, I want to display the another one. So just I put map.add layer and call the image and run the code. So now I want to add this another layer. So this layer I want to, suppose I want to display the result. I put the, suppose near infrared, then red and blue stressing I keep 98% and apply. So now if you check, okay, suppose I want to add, suppose I want to add the plated. Suppose low reflectance show the blue color, greater than high show the suppose green color, greater than I want to show suppose yellow color, and high reflectance for near infrared I want to show suppose red color. Then apply. So now if you check the result and compare the result with the previous layer, so if you check, so red for the near infrared, it's indicating about that high reflectance. Okay, we find out the vegetation this type of place is the vegetation, and we find out the near infrared, it reflects high. We find out the high reflectance. So healthy vegetation reflect strongly in near infrared. Okay, so near infrared reflect strongly. So this type of place near infrared strongly find out because it's a healthy vegetation. Okay, you can see the layer from here. So this is my healthy vegetation. This type of place is the healthy vegetation. So that's why I find this type of red color. And this red color, if you check the result from near infrared, so this type of near infrared is strongly reflected. Okay, healthy crops reflect strongly in the near infrared band and less in the red band. So now let's check the another one, red band. So I want to add the another, suppose red band. So in this case we find out the solution. Suppose we find out that NIR, this it strongly reflected by healthy crops. Okay, so we find out that near infrared is strongly reflected by healthy crops. Suppose where I find out the healthy vegetation or healthy crop, it strongly reflected. But red, what is the red band? Suppose for the red band, what happened? For the red band, it opposite, less reflectance. Okay, so strongly less reflected by healthy vegetation, healthy crops. I put the crops. Okay, so we find out that, suppose if you check, I already checked the result. So near infrared band is strongly reflected. If you check the value, suppose I want to check the value. So this type of place I want to check the value. So click on the inspector tab and click. It's a strongly reflected by near infrared. So just click. So now we find out that near infrared is 124. You can see very high. Okay, it's very high. Pixel value is very high. But on the other hand, if you check, we find out the red is very less, only for 71. Okay, but near infrared show the 184, very high reflectance value. But for red, we find out only for the 71, very less. So that's thing we find out that option healthy vegetation or healthy crop, always for any study area, healthy crops strongly reflectance, high value for healthy vegetation for the near infrared, and red band is strongly less reflected by the healthy vegetation. And also check the value, you can see we find out the 184 for near infrared band, very high. And on the other hand, healthy vegetation show the very low, less reflectance value, red 71. Okay, and it means that stress vegetation. Okay, so it show the stress vegetation, suppose less value. And so now suppose I want to check another, suppose I click on here, so it show the not vegetation, it's the low vegetation. If you check the layer 2, so there is no vegetation, just click on here. So now again, so we find out that red is very high. So if the red is very high and near infrared is very low, then this type of place have the stress vegetation or low vegetation, or this type of crop have the stress. Suppose in this case, I just simply take this, okay, just I simply short my study area. I take only for the one land. Suppose I just take the only for the small land. Suppose this is my agricultural land or cropland. So this is my agricultural land or cropland. So I simply short as my area. Then I want to check only for this boundary, what happened. Suppose just I take, suppose this is my agricultural land. So for this land, I want to check where I find out the healthy vegetation and where I find out the stress vegetation for this boundary, only for this land. So just run the code and check what happened. So we find out this type of result. So this is my one land. So for this land, I want to monitor stress vegetation and healthy vegetation. So now how I can check it? Just click on here, just open the near infrared band. And I stressing, suppose 98% I keep. And then I add the plated. Suppose low reflectance value I want to show as a blue color for low reflectance value. Then I just simply put here greater than, I put suppose this type of green color. Greater than I want to show suppose this type of yellow color, and high reflectance value I want to display as a red color. Okay, simply put red color. So red is indicating about the high reflectance value, and high reflectance value indicating about the high good vegetation. Okay, so this type of red color indicating about the good vegetation area. Okay, this type of place have the good vegetation. But if you check this type of green color or this type of place, we find out the stress vegetation. It's not the good vegetation. Okay, also you can see this type of place, I think there is no vegetation. It shows this type of low near infrared value. Okay, so now compare the result with this. Just I simply stressing, and I want to add suppose near infrared, then red and blue, stressing 98% I keep. So now if you check, just apply. So now if you check the result, so you find out that this type of red color indicate about the high or very good vegetation. Okay, you can see this type of it is very good vegetation, but it's not the vegetation. This type of is the less vegetation. Okay, suppose I just click on here and check the value. If you check, we find out that near infrared is very high reflectance will find out. Okay, 193, but red is very low. But if I just click suppose this place, I click on here, then we find out the red is very high. If you check, red is very high, 186, and near infrared is very low, 163. Okay, so you always remember that for the reflectance value, near infrared is strongly reflected by healthy crops, and red is strongly less reflected by healthy crops. So from here we find out that if near infrared is high, then it will be good crops, okay, or healthy crops, and if the red reflectance value, is low, then it's stress vegetation. Okay, so we can get this type of things. So you can see we talk about the reflectance. We are just talking our satellite. Where is my slide? Yeah, this is the slide. So we just talk about the land surface reflectance. Okay, so how we can easily connect this land surface reflectance with our agriculture precision. Okay, so we just talk about that near infrared and red. So near infrared reflectance, it provides the high value, okay, for the good vegetation, but red for the good vegetation you find out the less value. Okay, this reflectance value. Not only for that, if you check other satellite imagery, suppose Landsat, Sentinel, there are a lot of band. Okay, and every band have stored different reflectance value. Suppose for the Sentinel, if you check, we can easily get Sentinel 2. It show the different types of bands, B1, B2, B3, B4, B5. So different types of band stored the different types of reflectance value, surface reflectance value it is stored. So further let's discuss about this type of things. Example. Okay, so now we talk about another topic. Suppose application in precision agriculture. Suppose we find out this type of band. So now I want to calculate the vegetation indices. So vegetation health monitoring. So how I can monitoring vegetation health.
Monitoring, not monitoring.
Yeah, okay. So monitoring vegetation health. So there are a lot of way to identify vegetation health. So just we take the reflectance and check the vegetation health. But it's just reflectance, but I want to use some other method to monitoring vegetation health. So for that we can use a one method, it's called the indices. Suppose I create the ndvi. Okay, so it's one kind of vegetation index. So value high value, suppose I find out the high value high value, it means that good vegetation, good vegetation. Okay, suppose low value, it's called the stress vegetation. So not only for that, we already know lot of index is available, but in this case I show the example for that ndvi. So now I want to compute the ndvi and I can easily check the high value and low value, and I can easily identify for the crop health. Okay, so let's go and try to identify. So we just take a variable. Suppose I put the variable name is the ndvi, and then I just call my image. So I take a variable, suppose, and just put the image, and I apply, suppose, normalized difference between two band, near infrared and red. Okay. So just we simply compute and show the result. Suppose map dot add layer and show the ndvi and run the code. So now I show the ndvi map, and high ndvi value indicating about that good vegetation, low ndvi value indicating about the low vegetation or stress vegetation for our crop. So just click on here, and I want to display suppose stressing 98%, and I want to show suppose stress vegetation this type of color. Get at the end show this type of, suppose, or I suppose this type of, okay, Java yellow color, and good vegetation show suppose this type of green color, just apply. So now you find out this type of, if you check for this type of place, we find out the yellow color, so it's not the good vegetation, it's a stress vegetation. We find out this type of place, and sometimes suppose I think it's a water body for this, so that's why we find out this type of water in here. So now we find out this is the, where we find out the high vegetation, low vegetation, we can easily get this idea, and from here we can easily get where is the, find out the good vegetation, where is the, find out the low vegetation. So this type of place, if you check the value, just click on here, we find out, you can see near infrared it show very high, so red is very high, means that it's not the good vegetation. Okay, so we find out if you check 0.1 value, okay, 0.1 stress vegetation, but if you check suppose this type of place, it show very high ndvi value. If you check 0.4, okay, 0.4, and if you check suppose this type of place, it's a water body, it show the negative result, you can see the negative. Okay, in this time if you check r is very high value, okay, I reflectance r is very high, and we find out, you can see the green and barren land is also blue is also high. Okay, so green is always, green is high reflectance of water body. Okay, you always remember that green band is high reflectance of water body, always we find out the high reflectance value for the water body. Okay, so we find out this type of place look like that.
Sir,
Yeah, please.
this all procedure for monitoring now the health vegetation using the NDVI, the reflectance, can also be done using the UAV imager, the
Yes.
drone imager.
Yes. So I'll show you that also. Suppose if you check, where is our drone image? Yeah, so this is our one kind of drone imagery. Okay, so if you check this drone imagery, I want to monitor suppose NDVI. Okay, or if you check the imagery, click on here, and we also find out B1, B2, B3, B4. Okay, B1, B2, B3, B4, B1, B2, B3, B4. So now I want to check the reflectance value. Suppose I just click on the inspector tab and click on the vegetation. Okay, so now if you check which band show the high value, okay, suppose it show that B4 is the high value, So B4 is the near infrared, okay, and B1 is the red, okay. So how I can get the idea? Because for the vegetation, near infrared band is show the high reflectance value, and red band show the low reflectance value for the vegetation area. Click on here again, you can check the another example. So you find out, okay, so near infrared show the high, and B1 it's the red, it show the low reflectance value. So now I can simply apply. Suppose I want to display, suppose I want to display only for that near infrared. So click on here. So near infrared is the B4. I is stressing suppose 98% and apply. So it look this type of color, but I want to add the plated because it's a, okay, so I put the stressing suppose 3 sigma. Okay, just a minute. I think they are visualization need to add the reflectance value. Okay, so it already calculated that for this minimum and maximum reflectance value. Okay, for this place, minimum and maximum reflectance value you need to calculate, because it's not the satellite imagery, it's a drone imagery. So that's why I need to calculate the minimum and maximum value. So B1 mean and B next one is calculate about that. So it computed the value. Okay, just a minute. And now, okay, so let me check now. Click on, this is the NDVI map we computed. Okay, so just keep image. So I want to put the B4 and apply. Or B1.
Normally,
Okay, show the B1.
normally, okay.
Okay.
Normally, I see the drone image has only 3 bands, but this one has 4 bands.
4 bands. Okay,
Or it depends.
yeah. So they also use here another band they also need to create. Okay, and we can also draw an image. So further we also need to pre-process using the metaphase, or also different types of software or tool we need to use to create this type of band. Okay.
We will also cover this training.
Yeah, I also try to show you that also how we can easily create this type of band. Okay, it also showing, but I think B3 is also showing, but near infrared band is not showing in here. You can see we also find out the B1, B2, B3, but when I display the B4 near infrared band, because it's created,
Yeah.
it's created by
Yeah.
using this 3 band, it created the B4 reflectance. So that's why I think
Yes.
it's not display, but we also display that others. But when they compute the NDVI, if you check for the NDVI, they are used at the B4 and B3. Okay, B4 is the near infrared and B3 is the red. I think they are also mentioned in here. But if you just put here the B1, then check what happened. B1 and run the code, because B1 is show the low reflectance value for vegetation.
Sir,
Yeah, please.
I think because this drone image normally may be taken by using multispectral sensor, which shows the red,
Yes.
green, and the blue.
Yes.
But if we use that thermal sensor, including the near infrared and the thermal bands, we will have multiple bands, more than 3.
Yes. So if you check, suppose click on here and click. Okay, so near infrared it show the high value. Okay, red it show that this type of value you find out in here. And B2 is the low. If you check, B3 is the low, you can see. Okay. Suppose in this case they are mainly classified sugarcane area. Okay, if you check for the sugarcane area, they compute the value. Suppose this is the sugarcane field area. So this type of place have the sugarcane field area. Okay, this is the ground truth data. They make that digitized, and further from the sugarcane they compute the reflectance value. If you check, click on here, then we find out the result for sugarcane area. For the sugarcane area, we find out the high value is the B4 and low value is the B3. Okay, so that's the region it use here the B3 in this place. Okay, because B4 is the high, because their main target is for the sugar cane, they are also identify. So this is the ground truth data. So now for the ground truth data, they are check the reflectance value. Okay, so what the reflectance value? So you find out that high reflectance value is the near infrared B4 and low is that B3. So that's the reason they compute the NDVI using this B4 and B3. Okay, and they get this type of NDVI. And further they are make the classification. So I'll show you that later how we can easily do it. And now apply. Okay, so it show, suppose it's not only for the sugarcane area, it also have some trees. If you check, we find out this type of trees or forest. Okay, so we need to just work with the sugarcane. So this type of place is sugarcane, it's a forest or trees. Okay, it's a trees. Okay, so we can also monitor this type of things. And not only for the NDVI, we can also use suppose EVI. So when you apply the EVI, okay, so EVI for high biomass crops. Okay, so you just simply apply the EVI. Where is the high biomass crop, we find out. So we try to apply the EVI or dense area. Okay, dense area. So I think in this time when you apply the EVI, then we find out the more better result. Okay, so when you apply the EVI, so you also try to apply the EVI. Okay, just apply and then check the result. So I put this assignment regarding this topic. So you also try to create the EVI and then check the result also about that. Right. As well as you also use another one. So it's called the NDRE. Suppose NDRE. NDRE, it's mainly used for nitrogen status monitoring. For nitrogen status monitoring. Okay. Suppose NDRE. So I simply search on the Google and check the formula. So it's called the normalized difference red S. Okay, is a metric that can use to analyze the whether multispectral image contain the healthy vegetation by measuring the amount of the chlorophyll in plant. So we also try to apply this normalized difference red S, and there's a lot of application. If you check, this is the formula. Okay, so you can also apply for the Sentinel-2 also. Okay, for that. And it's the metric that can use multispectral imagery healthy vegetation by the measuring the amount of the chlorophyll in plants. Okay, how much chlorophyll is available in the plants. So we can also use this NDRE and monitor the plant. Okay, it calculates the near infrared and red S spectral bands. So red S band is only available for the Sentinel-2. Okay, red S band is only available for the Sentinel-2. So that's the region we also use the red S for the Sentinel-2. So you also try to compute using the Sentinel-2 and check the result for any cropland or any crop field. You also try to apply the Sentinel-2 and compute this equation. This equation is that NDRE okay, and this NDRE is also help you to identify for nitrogen status monitoring. Suppose high NDR value is indicating about the high nitrogen status, and low NDW value, so the low nitrogen status monitoring. We also use this type of equation. Basically, it's identify the chlorophyll content on your vegetation or cropland. This equation. So you also try to compute this, and we can easily identify a stress area using this way. Okay, suppose guide irrigation or detect the pest or diseases early. Suppose we find out this type of place is the low this type of place, it show the this type of color, it means that this vegetation is not good. So this place, what happened for the stress water, or we find out that suppose some detect the pest, okay, or guide irrigation. So this type of place we need to provide the water, then it will be work much well. We find out the well vegetation. Okay, so this is the way. So I will try to show you the roll up step by step, then you can easily get the idea. As well as we can also use for the crop type mapping. Okay, so this is the one kind of example for crop type mapping. If you check for the drone imagery, so for the drone imagery we try to identify for the sugar cane area. So what I need, suppose for the sugar cane area, I simply take this type of place is the sugar cane from my drone imagery. From my drone imagery, I simply take this is the sugar cane, this is the sugar cane, this is the sugar cane. So this is my training sample. So after that, we are just applying the machine learning. Just applying the machine learning model. So if you check in this time, we are just apply the machine learning model for random forest. Okay, random forest machine learning. Simply apply, and further we can simply spill the data set. 75% data for train and 25% for the testing. So same process for the land use land cover class. We I to discuss about that. Same process, just apply. But in this case, we find out the more better result because it's a drone imagery. Okay, so this is the random forest. This type of red color indicating about the sugar cane area. Not only for the, we also calculate the area. So if you check the area, how much area for the sugar cane, how much area forest. Okay, so just we take the only for the sugar cane, we take all of, you can see sugar cane forest, build up barren land. We take all of classes and make the classification. So then we can easily make the crop type mapping also. So I also send you this code link, also try same process. Okay, for the land use land cover, but in this case we are just using the drone imagery. Okay, and drone imagery give you the more better result than spectral imagery. Okay, and then yeah, please.
Can I see how now you have merged those ground truthing data and the trend data?
Which one? So this is sugar cane.
Yes, you have. This is sugar cane. You have the ground truthing before training the class of in your code there.
Okay, you can check.
Yes, I think you had the ground truthing data for sugarcane, is it? Or you?
Okay, so its ground truth is not need because it's very high resolution. We can simply zoom and we can easily.
You can see them
Yeah.
on the image.
Yeah, we can easily get the image because it's a drone imagery.
Okay, but you trained them by using the polygon, not a point as we normally
Yeah, we
do.
take the polygon. We take the polygon.
Okay.
For the build up. So and drone imagery we can easily classify it because it's high resolution. Okay, we can easily identify
Yes.
this is the sugar cane. So that's why we are just take the polygon.
But one day I tried to add the drone image in the Google Earth engine, but it comes with only the one failed because of maybe it has occupying a large space.
Okay, so this drone image, basically this drone image, do you pre-process or not?
Yes, I didn't pre-process.
Okay, we need to pre-process this drone image first. Okay, suppose Aegis soft. So I'll show you the suppose drone image. Suppose drone image pre-processing. So already you can check the lot of tutorials available how we can easily pre-process this type of drone imagery, as well as we also get. So
I know the Agisoft software.
Yeah.
The Agisoft membership.
Yeah, we can also use this type of things to make the drone imagery into the spec. We can add some different types of when we create, and further we can also use it. And now also some AI is also available, so to create this type of drone imagery. Okay.
So which software can I use to pre-process so that those drone image can drone images can be added in the Google Earth engine.
So Agisoft you can also use.
I normally use the Agisoft in making the also photo to make the 3D.
Okay. Oh, I think it also helps you for the LiDAR data also.
Agisoft Metashift.
Yeah.
We normally use the Agisoft to combine the drone image which have overlapped to create the auto photo so that we can extract maybe the digital elevation model, file resolution, extract some of the features to create maybe a topo map.
So we can, for that we can use some, suppose commercial software is available, as well as also some open source software is also available. Okay. Suppose for the commercial software, you can also use the Pix 4D. Suppose Pix 4D Mapper. So Pix 4D Mapper. So it's one kind of commercial software. We also use it to create. It's a commercial software, yeah.
Yes, I know Pix 4D also, but my question is.
Yeah, please.
Before my question is before adding the drone image in Google Earth engine, you have said you have to pre-process.
Yes,
it.
yes. Yes.
So I pre-process that drone image to reduce, or because pre-processing it is normally you have to reduce some errors so before using the image. What error am I going to use in drone image? While the drone image I already complete.
So basically we need to take the drone image, further we need to pre-process to make the TIFF format, make the bands, different types of bands. Basically any image we find out the B1, B2 and B3. Okay, normally any imagery, but further we need to, this type of imagery we need to suppose georeferenced. If you check now, this drone imagery is also georeferenced. Okay, as well as this drone imagery have this type of band. So this type of things we need to do using this type of software. Okay, suppose you can see it's also georeferenced also, this type of imagery. So normally drone imagery it's not we need to georeferenced again. Okay, and further we can easily use it. Suppose you can see this place is the georeference, so then we can easily just overlay, we can easily get the better map. Okay, so I'll send you some sources how we can easily make the pre-process the drone imagery. You also try to follow it, then I hope it will also work, no problem.
Okay, and if now time will allow on the next coming lecture, coming class, you can try to instruct me on how to pre-process the drone images before importing them the Google Earth engine.
Okay.
But also will send me those books and some video to check.
Okay. Okay, so then suppose as well as if you check nutrient and water stress detection, suppose how I can do it. For that nutrient and water stress detection. So in this case, we can simply remember that low NIR and higher rate. Okay, suppose low near infrared band reflectance value and higher rate reflectance value indicate the water stress or nutrient deficiency. Okay, it's indicating water stress or nutrient deficiency. So now by monitoring the change over time, and farmers can apply the variable rate fertilization and adjust your schedule. Okay, Suppose if you check where for this land, where is the low NI level, we simply check it. Suppose just I open the NIR and then apply. Suppose I put the plated. Suppose I want to show the high low value, I want to show suppose this type of blue color. This type of blue color. Suppose get at I to show this type of yellow color. Get at show this type of red color. And get high I show this vegetation. So now you can easily get the stress vegetation. So if you check, suppose if you check this type of place, we find out the stress vegetation. Okay. And this type of vegetation is not good. This type of place, this vegetation is not good. Also you can see this type of place vegetation is not good because due to the deficiency of nutrient or water stress in this type of place.
Water stress in the plants, not soil, is it?
Plant. We talk about the crop. Okay.
Yes.
Crops. So now you find out this type of place if you check. So further, we can simply take the schedule. So basically, if you get the lower NIR value and higher rate indicating about the water stress and nutrient deficiency of crops. So I see we'll put the crops. So now we can easily get the idea from here. Okay. So here I need to the irrigation or here I need to apply the fertilizer. Okay. Due to the nutrient deficiency, we can easily get it. As well as we can also use here the soil property. So we talk about the further class how we can apply the soil property, and we can also correlate the yield prediction also, no problem. Okay. So I hope you also get the idea. So just we talk about in our slide, suppose we are just how we can easily apply the reflectance value. Okay. So not only for that, there's a lot of land surface reflectance we can also find out. Suppose you can see Modis Terra, Modis Aqua, okay, then Xiaomi NPP, Landsat, Sentinel. So different types of bands are available. So this type of band we simply correlate with the agriculture. So I also write all of those. You can see land surface reflectance, okay, how it will be worked, and which indices provide you the which information. You also get the idea from here. And also Modis provide you which product, we also check in here. Okay.
But some models provide surface reflectance, but does not have near infrared, maybe bendy, red bendy, or green bendy. You can't get those bands, is it?
No, basically it also provides the another types of reflectance band for the Modis. Okay. It's provide another types of band. So then we also need to use the different application for the Modis, as well as Modis also provide some ready-made product. Suppose land surface temperature, vegetation indices. Suppose Modis NDVI, Modis EVI, as well as evapotranspiration or primary production, okay, or vegetation continuous field or burned area. So this type of things we can simply correlate with the agriculture, and further we also do these different types of application we can also do using this way. Okay, as well as you can see I also add all of satellite imagery. Okay, so I also send you this slide. You also try to read the full slide, then you can get a lot of idea which sensor or which satellite provide you which information you can easily get, and how we can easily connect this type of sensor in our agriculture application. Okay, you can see the evapotranspiration and how to correlate the evapotranspiration with the agriculture. Okay, so if the evapotranspiration is the high, then what happened for the agricultural land? Okay, then satellite and sensor evapotranspiration. Okay, so it's very long slide. So I also send you this slide. You also try to read it, all of data about the sensor. Then how to precipitation is influence the agricultural land. Okay, different types of satellite for agricultural precipitation, suppose global precipitation system or satellite or chart satellite imagery. Okay. Then also soil moisture, it's very important indicator for your agriculture precision for the soil moisture. Okay, because depend on the soil moisture, we need to provide the water irrigation or not. Okay. So different types of things we try to add in here. Then NDVI application, carbon monitoring, lip year index. So further step by step, I try to explain all of those. Then you can easily get the idea. Then how to apply the SAR data, mainly Sentinel-1 SAR data in the agriculture monitoring. Then land cover mapping and optical versus radar. Okay.
Sir,
Yes, please.
can we make the land, you can use land cover map using Sentinel-1?
Yes.
Is it possible?
Yeah, it also possible. And I already published a video in my YouTube channel about that. You also follow that. So I'll just show you that. Simply search here Sentinel-1 LULC. Then you can easily get this video. You also try to follow the video. SAR imagery, how to make the land use land cover classification, because SAR imagery is very helpful for that when you work with cloudy region. Okay.
Yes.
And we can easily get the better satellite imagery, and we can easily apply this type of things method. No problem, easily.
But they say it is said that it is difficult to interpret the radar image visual.
Yes. So further need to apply some different technique to identify, and we can also combine the radar image with the multispectral imagery. Okay, then we detect some training sample.
Okay.
Then we just simply apply the.
So we will cover in this training.
Yeah, I
that
also
one.
cover.
Okay.
No problem. No, I'll show you the process, because we also basically all of sensor in our slide, all of sensor I try to complete. If you check this slide, so all of those I try to complete and show the example. Sentinel-1 is very important for the agriculture, for structure. Suppose different types of crop structure we can also get from here also.
Okay.